guys, here's our first question on measurement. Now it says that the perimeter of a square is 28 centimeters. What is the area? Bear in mind that the perimeter is the distance around, and over here on the right you see me have a square. The square has 4 sides, which means that in order for me to determine the area, I must find the length of one of those sides. So all the sides are equal. So if the perimeter is 28, to get the length of one side, I'm simply going to have to divide 28 by 4, which means that one side would be 7. And you can check it. 7 plus 7 plus 7 plus 7 would give me 28. Now, what I want is the area. I will know that the area of a square is equal to L squared. So the area in this case would be equal to 7 squared, which would be equal to 49 squared centimeters. Now, when you're in an exam scenario, you wouldn't have to go through all of this. What you need to remember is that the perimeter of a square is 28. All the sides of a square is equal. And the square has 4 sides. So we simply just need to divide the 28 by 4, which would give me 7. 7 is the length of any side of the square. The area is equal to the length squared. So I simply just square that 7. So I didn't necessarily have to draw a square to get this question right. Here's our second example of a measurement question. The area of a rectangle is 30 square centimeters. If the length is half and the width is multiplied by 6, then the area would be. Now, we know that for a rectangle, the area is length times width. So initially, the length times the width is equal to 30. Now it says that the length is half. So I'm going to have length over 2. And the width is multiplied by 6. So I'm going to have 6 width. Now, when I break this down, what I'm going to have is that I'm going to have 2 into 2 is 1, and 2 into 6 is 3. Now, bear in mind that we can put the constant at the front, which becomes 3 times length times width. So, in a balance equation, if we multiply one side by 3, which is the length times the width by 3, then I'm going to have to multiply the other side by 3, which is 30. So this becomes 3 times 30. So my new area would be equal to 90 square centimeters. Now, simply put, we don't have to go through this entire process to do this question. Whatever impact is done on the dimension will affect the area in a similar way. So when I multiply by 6, or when I half and then multiply by 6, this is what is going to happen. What I simply need to do is to half the area, which is 30. So 30 over 2, which would give me 15. And then I simply multiply the result by 6. So all this times 6, which is going to give me 90 squared centimeters. Or, since you half it and then multiply by 6, you could say a half times 6, which is equal to 3. And then you multiply that 3 by the area, which is 30, which still gives you 90. So there are several ways that you could attempt this question. So the answer here would be B. Here's an example of a third question. Here we have a cylinder, and the question is the volume of the cylinder above is. Now, of course, there are several ways to do this. We can always go with the formula, because we know that the volume of a cylinder is equal to pi r squared h. However, notice we didn't get the radius, we got the diameter. So to get the radius, we divide the diameter by 2. So the volume would be equal to pi. And of course, all the answers is in terms of pi. So I wouldn't need to change the pi to anything. So I would have pi times half the diameter is 4 squared, times the height, which is 5. Now 4 squared is equal to 16, and 16 times 5 is equal to 80. So what I would end up with is 80 pi cm cubed. However, what if I don't remember the formula? This is like a prism, or some persons call it a circular prism, which means that it has a uniform cross section. As you can see, it has circles going right throughout it from top to bottom. So all we have to remember is that for all prism, the volume is equal to the base area times the height. Now the area of the base is actually a circle, and the formula for the area of a circle, you know, is pi r squared, and the height is 5. Right? So that is how we'll actually get the pi r squared h, without actually trying to remember that the volume of a cylinder is pi r squared h. So from this, you can remember that the volume for all prisms, and prisms have uniform cross-section, is the base area, or the area of the cross-section, times the height. Alright, and this works in all cases when you have prisms. So once you can find the area of the cross-section, you multiply by the height. Please remember that for a circle, you must look out for whether or not the radius is given or the diameter is given. If the diameter is given, then we divide the diameter by 2 to get the radius. So in this case, my answer is 40. So the answer is D. Here's an example of our next question. The perimeter of a cane field is 20 kilometers. On a map, this distance is 4 centimeters. The scale of the map is. The first thing we have to understand is that a map is a scaled down version of reality, which means that if I have 1 kilometer in real life, then on a map, that 1 kilometer could possibly be 1 centimeter. It's very important that we understand why, because we couldn't possibly fit 1 kilometer on a map, because that would take an extensive amount of paper. You would have so much paper that having a map becomes totally pointless. So what we do is to scale down reality. So we use smaller units to represent large units. However, that is why we now need a scale, which we use to interpret this. The scale tells us, for instance, you have 1 to 100. That is saying 1 centimeter on a map is 100 centimeters in reality. Right? So let us look at what we have first by comparing them. On the map, so I'm going to have my map, which is 4 centimeters on my map. And this is, of course, reality, or underground, all right, in real life. This is being represented by 20 kilometers, all right, which is the actual distance. Now, for me to compare this, I'm going to start by breaking it down to one unit. So if 4 centimeters represent 20 kilometers, it means that 1 centimeter would represent 5 kilometers. We're good there. Now, to get the scale, I need to know how much is 5 kilometers in centimeters. All right? So I can know it's 1 to how much centimeters. So what do? It might be difficult to go directly from kilometers to centimeters, but we can go from kilometers to a more familiar unit. So what I could do is to change the 5 kilometers to meters, because we know that 1,000 meters make a kilometer. So we multiply the 5 by 1,000, which would become 5,000. And then, of course, you want to move from meters to centimeters. And we know that 100 centimeters make a meter. So we multiply this now by a further 100. So we add those 2 zeros there. So the scale becomes 1 to 500,000, which really means that 1 centimeter on the map is really 500,000 centimeters underground. So the correct answer here is D.